Our game's really taking shape now. We've got asteroids, we can shoot them, and they break apart into smaller pieces. But it's not going to be a very hard game if our player ship can't be destroyed. So let's code our player ship collisions. Hi, and welcome to Bytes and Bits. I'm Bob Grant, and this is part 6 of the Asteroids programming course. As you saw in the introduction, we've got as far as being able to shoot the asteroids and have them break down into smaller pieces. But as yet we haven't worked out the collision detection between the player ship and the asteroids themselves. So that's exactly what we're going to be working on in this lesson. So let's get straight in and see how we're going to do that. If we think about our player ship object getting close to an asteroid, at some point the two shapes are going to overlap, and this is what we're trying to detect to see if the player ship has been struck by an asteroid. If we think about what's actually happened here then, one of the points in our player ship object has now gone inside the polygon of the asteroid. And we've actually written the code for doing that already. We've already done our point in polygon collision detection. But we now need to run that a number of times, once for each point in our player ship, because we don't know which particular part of the player ship is the one which has hit the asteroid. But even looping through each individual point in our player ship doesn't give us the whole solution. We can actually have a situation where no points of the player ship have actually entered the asteroid, but one of the points of the asteroid has entered the player ship. So to get a complete solution, we'll have to make sure that we check for each point in the player ship going inside the asteroid, and then each point in the asteroid going inside the player ship. And if any of those points are inside the other shape, then we have a collision. Going into our code then, we already have a function called point in polygon, and that checks if a point is inside a shape then. So that's the one that we're going to be using. But what we now need to do is we need to create a new function which is going to check if two polygons are overlapping. So if we sort of flesh this out with a sort of a pseudocode, we know then that we're going to need to create this function. It's going to accept then two of our vector shapes. So normally one of those will be our player ship, one will be an asteroid. But again, we can make it general purpose so that we can detect any two polygons, which again are all conforming to our same specification. So in other words, we have the shape, it has an array inside it called points, which then dictates all of the different points that make up that shape. It has a rotation value which tells us what the angle of rotation of the shape is, and it has a position object with x and y coordinates telling us where on the screen that shape is positioned. So what we need to do then is the first thing we're going to do then is we're going to start looking at each of the points in one of our shapes. So if I bring this in here, so really we're going to again go through each point in shape number 1. So we're going to look at shape 1 pushing inside shape number 2. And what we need to do first of all, remember the points array gives us a set of points which are relative to the origin of that shape. So we first of all need to translate the point x and y coordinates into screen x and y coordinates. So we're going to have to do a rotation to get it the right angle, and then a translation to get it to the right place on the screen. And again, all of this we've already done in our drawing code. So you should be able to find all the answers in there. We then need to do an idea of checking if that point is inside the other polygon. So if I come in here, so we can say, so if, and again we're going to use our point and polygon code. So if the point that we've now want to check is inside shape 2, then we have a collision. And we're going to have to somehow get that collision answer back to our code, which has called this function. So again, we're going to have to work out how to do that. And really that's our loop for this. So we really then want to just simply do the next point. So going through each point in shape 1, getting its true coordinates, checking if it has actually moved inside shape 2, that then signifying a collision, and then just simply go through each point. And then of course for the next of it, we will simply need to do exactly the same then for our point in shape 2. So we're going to go through each point in shape 2, get its true coordinates, check if it's inside shape 1, and then that signifies a collision. And at that point then, we will need to, as I say, return the collision information to tell our calling function whether or not we've actually got these two shapes colliding. And again, we need to work out as well, this returning the collision, we want really to make this code as fast as possible. So at any point in either loop, when we get a collision being detected, we really want to send that information back. So have a think about how we could do that. But that then really is the pseudocode then for this Polygon in Polygon collision detection. So I'll give you a few minutes then, well, as long as you want really, to get that code written. So create a function called Polygon, which is going to detect if two vector shapes have collided and return back a true or a false value. So see you in a second. So here's my version of the Polygon in Polygon function. So as I said, we've got the function and it accepts then two parameters, one shape and a second shape. And again, as long as those shapes conform to our what we call an interface, in other words, the exact makeup of the object and the attributes it has, then we'll be able to detect if these two shapes have collided. Now in my loop, so here's the loops that we were talking about in the discussion. I'm going to need to generate points that we're going to be testing. So I'm doing it in multiple stages here just to make sure it's all easily explainable. But remember, we're going to have to take a point out of our shape. We're going to have to rotate it. So I'm going to get a rotated version of the point, but that's still with reference to the center of the shape as the origin. And I'm then going to need the actual final test point, which will be that rotated point translated to the actual position on the screen. Okay, so we're going to take our first shape then. So shape 1, so we're going to then use our for loop. And we're going to use this iPairs function, which lets us take this array of points. So we're going to use shape1.points when that's an array of points. And this then lets us get both the index within the array and the actual object itself. So again, all of this is taken really from our draw vector shape function. So we're going to rotate the point. And again, that's straight from our using our function rotate point. And we're then going to translate the point to its position on the screen. So our rotated point then gives us the it moved round by that rotation angle. Our test point then, we simply add on the central position of shape 1, and that gives us the final x and y coordinates of this test point. So our test point then, we've again wrapped it up inside one of these Lua tables to make it into our sort of pseudo object. So it has an x and a y attribute. And again, that's what our point in Polygon function requires. So when we send in test point, it will be able to pick out the x, y coordinates and then compare those with the shape 2 points, which form up the polygon for that, and then give us back an answer which will be true for a collision and false for not collision. So really the idea then of getting this information straight back to our calling function. So if we get a part, so one point in our shape 1 inside shape 2, then that is a collision. There's no need to do any other calculations. As soon as one point is inside another shape, that is a collision. So at that point, we'll just simply say, forget about everything else and just send back a true answer. And all the rest of this code down here just never gets executed. We go straight back. And of course, that means that our code is executing, is getting the answer back as soon as it's possible, and not wasting time then going on and doing pointless more tests. So this block here then, that is the testing for shape 1 entering inside shape 2. And the second one then is almost identical, but we're now doing then looping through shape 2's points and then checking if any of those are inside shape 1. And again, as soon as we get a collision, we send that information back to our calling function. And the idea then is that if we get through this for loop and then all the way through this for loop, then we've checked all of the points in either shape being in the opposite shape. And so if we actually get to this point in our code down here, then we just have not had a collision. And at that point, we just simply send back a false answer to our calling function. Now that we have Polygon in Polygon collision detection, we need to integrate this into our code to check then if the player ship and an asteroid have collided. So we really need to create a function that will do that. So if I just scroll off a wee bit here, I've actually already created that function. So check ship crash is going to detect if the player ship has hit any of the asteroids. So if we have a look at how this works then, it's basically a loop which is going to work through every asteroid in the asteroids array. So remember, we have this array called asteroids, which every element of that is one of the asteroids which is flying around the screen. Now, usually we've been using this idea of a for loop using that ipairs function to pull things out. But again, there's lots of different structures we can use in here. And I'm going to do this one using the while loop, because the while loop lets us have an exit condition. So in our for loop, that very much starts at the beginning and is designed to work its way through every item. But what we want to do here, as in some of our other areas, we want to actually exit from the loop early. So once we've found a collision, there's no point checking any more asteroids. That's a waste of time. We simply, as soon as we find the first collision, well, we've got a collision, and that's that. So I'm using this while loop then. So let's go through how this works. So our while loop has a set of conditions. And if these conditions are true, then we continue to work our way around the loop. If this condition is not true, then that's the exit of our loop. So the first condition we have here is where it's going to go through each of the asteroids in the asteroids array. So we're having to create our own manual counter to count up and access each of the elements. So that's what I've done here. So I've created a local variable called index. And I'm starting that off at the value 1, because Lua tables and Lua's arrays are indexed from 1 and not from 0 as they are in quite a few other languages. So element number 1 is going to be our first element. And I'm saying here is as I count through the elements using this counter, if my index is less than or equal to, and let me just go to a bigger font size here. So that is the hash symbol. And if I put the hash symbol in front of a table name, it will tell me how many elements are in that table. So if the one we're currently accessing is less than or equal to the last element, so in other words, we've actually got a valid element, then we've got an asteroid to play with, so we can actually do the loop. And you can see down here within the loop then, so the very final thing I do in the loop is I increment that index counter so that the next time through the loop, we're looking at the next asteroid. So let me go back to the smaller font size. So we have then our second conditional here. And this is where we are detecting whether we've got a collision between the ship and any asteroid. So I'm creating this little flag called ship crashed as a little local variable there. and I'm initializing that to false so that we don't have a collision detected. And what we're saying in our loop then is if we've still got an asteroid that we need to check and we haven't yet found a collision, then we need to do the check. Okay? So as soon as we do find a collision, this loop will exit and we don't have to check any more asteroids. But the check we're doing then is we're saying this flag, which I've called ship crashed, is going to use our new bit of code called Polygon in Polygon. And it's going to check if the player ship has collided with the current asteroid we are looking at. So remember, we're looking at our asteroids table and we're picking out the element in that which is given by that value of index. And that picks out one asteroid for us to check. So remember, our Polygon in Polygon function returns back a true answer if we've got a collision and false if we haven't. So in this one here, we're basically saying catch the signal as to whether we've got a collision or not in this flag called ship crashed. And at that point, when we next go round our loop and come back here, we will have got a collision so that our loop will exit. And when our loop exits, we come down to this bit of code, and that simply sends back the value of this flag variable. So the idea here then is, if we come into our loop and we don't find any collisions, so we never find a collision, then our flag variable will stay at the value false, and that will return back the answer no collision. If we do find a collision, then as soon as we find the first collision, then our ship crashed flag will be set to true. We'll exit our loop, and then we will return back that collision detected value through this line here. So that's really then looking at our ship crash, and again using this while loop. So instead of using a for loop and forcing the loop to finish, we are now specifically stating when the loop finishes. So that can sometimes make it a lot easier to read, especially if you have a very, very complex loop which might have lots of exit conditions. If you're jumping out of the loop using the return or the break command in lots of different places, it can sometimes be hard to work out the logic in your code. Whereas if you use a while loop sometimes, then because we've got all the conditions specified here, we can see when the loop is due to exit. But again, a lot of this is down to your personal programming style. There's no right or wrong answer. There are just solutions that work and solutions that don't work. So that's the check ship crash function. We need to integrate that into our game code so that we actually do check for this at the correct time. So that's going to be done in our do play game function. So if I come up to do play game, so our do play game function, this is the main playing loop. So you can see here that we are doing our updating. And at this point then, I'm going to say if check ship crash, so if our player ship has crashed, then I'm going to create this new game state called state ship killed. And that is one I have defined up the top of the screen here. So remember we had our game states up here. So state ship killed, I've set that to 12 because it sort of fits in between playing and ending the game. And what we come down here then, so in my main tick function, where we decide which state our game is in, again I've put one in here. So if game state equals state ship killed, then we will go and run this particular code. So do ship killed. So if I come down to do ship killed, all I'm doing is I'm just printing a little message on the screen. So it was working very much the same as our game start and game end functions. I'm then putting on this wait for us to press the fire button. But what I've not done here is I have not cleared the screen. So if we look up at our other ones, we always clear the screen. But what I'm going to do, I'm going to leave it with a non-cleared screen. So anything we drew on just before the ship was killed will stay on screen. So we should be able to see the actual player ship and the asteroid overlapping. So just run through that again. We've created a new game state. So we've got our game state ship killed. In our main play game function, I'm checking if our ship has crashed, then we're going to go into this new game state. And this new game state then is one where we simply, in here, we simply then print up it's killed, so we know that we've entered this state, and it will leave all the graphics on the screen so we can see the actual collision. And then it will just wait for us to press the 4 button again and then go back into the play game state. So let's see if that all works. So let's run the code and come in here. And let's see then if we can go and crash into a ship. And there we go. So we have killed there. And again, you can see, if you look at the screen here, okay, the nose of the ship has just gone into that asteroid. So that's correct then. So let's come back out of that. I'll just press escape. Let's run it a second time. And let's see then if we can get an asteroid to crash into the back of the ship. Okay, so actually that's not very easy to see. So let's just run that again. There we go. Oh, just as bad. But you can see here that the back corner, the back tail point of our ship has now collided with this asteroid, and we've got that working. So we're now quite happy that our polygon on polygon collision detection is working, and we can now detect when the ship gets hit by an asteroid. So let's come back into our code. Oh, and while I remember, don't forget that you can download all of the code for this lesson from my website. I'll put a link in the description below, which will take you off to the project pages for the Asteroids project. So you'll get access to all the other lessons there and some notes on each lesson. But so the main thing is you can download all this code and you can then just copy and paste it into your TIC80. We've now then got as far as having our player ship be killed, and again, but at this moment it's through the asteroids, and we come into this function do ship killed as part of our game state. Now obviously at the moment we've just programmed that so that it pauses the display so we can actually see the collision taking place. But we need to do something a bit different to get our game going. And really what happens when the player's ship is killed then, we do need to do some sort of explosion. So at the moment I'm just going to make it make a sound. And then it wants to go into a little bit of a pause while we wait for that sound to finish and then reset the game, the player ship, and redisplay that to carry on with the game. And of course in all of this then, as the ship gets killed, that will obviously take one away from the number of lives the player has. And if the player runs out of lives, at that point we go to the game state where the game is over, or I think we call it state end at the moment. So there's a number of things to do to handle this player ship being killed. So what I'm going to work on is doing a little bit of a sound explosion in the do ship killed function, handling the lives, and then if we still are going to carry on with the game, I'm going to pause for a bit and then restart with the player ship back at its starting position. So have a go at coding that for yourselves. I'll put a little bit of a pause on there and then come back and show you what I've done. So see you in a wee bit. Okay, so let's have a look at this player ship explosion then. So we know here that as soon as the player ship gets hit by an asteroid, we go into this ship killed state, which calls this function here as part of its tick. So in this function, we're really going to set off the chain of events for the explosion. So we see here that we actually have this bit where I'm doing the explosion. And as I said, all I'm going to do at the moment is make a sound effect. A bit later on, we'll probably come in here and do some explosion effects. But we're just going to make a sound at the moment. We're then going to reduce the player lives. So I've created a global variable up at the top again. And that then, of course, is initialized to 3 when the game starts. I'm then taking one away from that. I've again declared a global delay timer. And again, I've declared it just as a generic name, so we can use this in different places. But I've declared a global variable at the top. So I'm setting it to 60, and then that will eventually count down to 0. And then we're really just saying we're going to change our game state to this new state, which is called the ship kill delay. And at this point, we're going to just wait a bit for all the explosions to finish and then decide what to do next. So this function here, it's only going to run straight through it. So we don't actually have to do any displaying here. It just sets off an explosion and then changes the game state to a different state. So if we now look at the kill delay function, so this is our do ship kill delay. What we're going to do is we're going to wait for the explosion to finish. So we're sitting here just counting down that timer. And once the timer gets to 0, then we're actually going to do something. If the timer isn't 0, we just simply keep looping round. And at the moment, because we haven't cleared the screen or anything, then everything will just stay on the screen in its current position. And again, we can have a think about whether that's what we want to do or not in a little bit as well. But for now then, we've got our delay timer counting down. Eventually it reaches 0. And at that point, we make a decision. So we're saying if the player lives has now reached 0, so there's no lives left, then of course that's game over. And we've already made a game over state, which is called that state end. Else, we're going to have to respawn the player ship. So we're going to have to reset some values in the player ship to get it back in the center of the screen, stationary and pointing in the starting position. So instead of putting it all in here, I've made a little function called reset player ship, because that's actually something we're going to need to do in a number of places. And at that point, once we've reset the player ship, then we simply go back into the play game state. So I've also made a couple of other changes which use this reset player ship, because once we come back into our play game state, obviously we need to have the player ship being reset back to center. But also, once we start our game, so even when we get to the game over state and then restart our game, we do want to reset that player ship again. So remember, we had a function called Init Game, and that was called when we move from the waiting for the play button to be hit and then going into the play state. So at this point here, we're going to say, so we put our game state to state play, we reset the player score back down to 0, we also then have to reset the lives back up to 3, and we have to reset the player ship as well. We also then need to regenerate the asteroids, and we're back playing again. So let's have a look at that going then. So if we do Control R and we run that, we can now crash into an asteroid, crash into it again, crash into it again, and that's now our game over. So come back out of this. You may have noticed as well, I've added in up in the top corner. So up in here, I've added in some player lives, and you'll see now that those get reduced down to 0. And the way I've done that is in our, we had a function, remember, which we called draw game info. So if I go to that, so if I go to draw game info, initially it was printing up the score, but what we're now doing is I've got a little for loop in here, which is simply putting little sprites up in the corner. So if I go to my sprite editor, I've designed a little sprite up in position number 1, and that's going to just signify the lives left for the player. So our player lives then is going to go from 3 down to 0. But when we display it in the top corner, we actually want to display, when we have 3 lives left, that's 1 player ship that's actually on the screen, and then 2 should be up in the top corner as your 2 spare lives. So that means we need to first of all then have player lives -1 as our value. But what I'm doing here is I am adjusting the X position of the little sprites by gradually counting back 6 pixels each time. So when count is equal to 0, I will be putting my sprite at position 230. When count is equal to 1, then I will be 230 minus 6, because I'm doing 6 pixels per count. And then when count equals 2, it will be 230 minus minus 12. Now, because I'm counting from 0 rather than from 1, that means I have to take an extra 1 away from my player lives. So I'm counting from 0 to player lives -2, and then drawing little sprites up in that top corner. And that gives me my correct number of lives. So that's got the general structure then of the player ship being killed worked out. But it's not quite right yet. So if we go back in here and start playing, if I let an asteroid actually hit the ship, what we'll find is when we respawn, if there's an asteroid actually where the player ship is, it will just continually kill us. We don't have a chance to actually move out of the way of that. So that's what we need to have a look at next. So to have a look at what we need to do, back in the code, if I go down to my doPlayGame function, what I can do in here is I can actually just turn off my collision detection and my player ship. So where we come in here, we have the draw player ship block, and we have the check ship crash. So let's just comment out that one there, which actually changes the state. So if we now run the code, we can see that we just have now the asteroids sort of floating around. And really what we're trying to do is our player ship is going to respawn in this area here. So when we respawn, what we need to do is really check if any asteroids are in the vicinity. So you can see at the moment we have asteroids spinning right through the respawn point. So if we respawn, we'll simply be destroyed straight away. So we need our code to sit there waiting until there's a reasonable amount of space between this position on the screen and any asteroid. So again, we've already written the code which checks for how far away an object is from a point. So really all we need to do now is just put a little delay loop in saying wait until we get no asteroids within a certain distance of this respawn point. So let's come back into the code and see how we can do that. So let me just put these 2 lines back in again. So we're back to our original program now. So in our ship killed one, we've already split it up now into this function which starts off the ship being killed, and then this function here which does the delay to wait for it to be respawned. So we still need to do this delay timer, and we need to then run that to make sure that our explosion effects, so at the moment just the sound effect, make sure that they have time to finish before we try to respawn. But what we now need to do, instead of in this bit here where we're going to do our respawn, we reset the player ship. But what we now need to do, instead of our game state going back into the state play, we're going to now have to go into a different state where we're going to wait for the respawn. So let's call it wait respawn. So we're going to create a new game state called state wait respawn. So let's copy that, and let's go back up to the top of our code here, and there. And if we come up here to our states, so let's put that in there, and let's make it equal 16. and then in our game bit here, so we want to in here, so we're going to just copy that one and put that in, and this is our state respawn, and let's just take that out there and that out there. So all I'm just doing is just putting in that extra state, and we're going to do ship respawn. Okay, so we've got that new game state put in now, and we now have to implement this function do ship respawn. So let's come down to our do ship killed one, and we'll put that in just after here. Oh, so it's do ship respawn, wasn't it? So function do ship respawn, and let's just copy that across and there. So we now have this state where we're going to check in here, and we're going to wait until the asteroids are not. We have a space for our ship to respawn without any asteroids getting in the way. But while we're waiting, we do need to keep the game going and the asteroids moving. And in fact, while we're doing our do ship kill delay and waiting for the explosions to finish, we do still need to animate the asteroids and the rest of the screen. So everything apart from the player ship needs to still be drawn in this state here. So have a think about how we can do this. So we need to make sure that we keep the game display going in this function, and also keep the game display going in this function as well, but wait until we have a clear space to respawn the ship, and then we jump back into the play game state. So I'll give you a delay on that, see if you can work that one out, and then we'll come back and I'll show you my solution to it. Okay, so if you've got that working, brilliant. If not, follow me through with my version here. So the first thing that we're going to do is we need to decide how far apart we need the asteroids to be from that respawn point. So I've created this little global, well, I've given it in capitals because that sort of signifies that it's a constant. But we've created this item here, and I've set it to 30 pixels. So that lets me then have a named value which I can use as the minimum distance that the asteroids need to be away from the respawn point before we allow the ship to be respawned. And again, by doing it this way, I can simply change that number and it will fine tune it if we haven't quite got it correct yet. So again, 30 pixels is a bit of a guess. What we then need to do is we already have our game states working, so that's all doing the correct things for that. But we now need to come back down into here and have a look at our delays. So our game, when it's running, it clears the screen and then it does updating and drawing of the various parts of our game. Now, we said that we want to keep that going during this explosion and the delay, or at least a lot of it going. So what we can do is we can copy this block out, so from the clear screen all the way down then to the end of draw game info, because that's the entire game being run. And then when we get into our ship dying functions, so our first one here, the do ship killed, again, that's only going to be live for one tick, so 1/60th of a second, and that just really sets everything going. So it does our sound effect and sets our delay timer going, and then changes immediately to the game state of this kill delay. So inside our kill delay then, as part of that, we then need to paste in that game loop code. So that's all just pasted in there. But what I've done, just so you can see that all I've done is taken a few bits out, is I've used these comments to take out a few of the lines. So in our updating code, we don't need to check our player buttons anymore because the ship's been exploded, and we don't need to move the player ship because of course it's exploded. But we do need to move our asteroids so they keep moving around on the screen. We don't need to check if the ship's crashed anymore, but we do need to keep any player bullets that happen to be already in the system. We need to keep those going through and also keep checking if they are going to hit asteroids. So our updating procedure now just becomes moving the asteroids and then handling our player bullet movements. In our draw function then, we need to draw the asteroids, but we don't need to draw the player ship. We do need to keep on drawing the player bullets because of course that's part of what might be finishing off. And we do need to draw the game info screen up on the top, the scoreboard and the number of lives left. So that of course then gives us the game display continuing to go while we wait for the explosions to finish. And so this is the same code as we had before then, so we're waiting for our explosions to finish by just counting down that delay timer. And when it gets to 0, then if we've lost all of our lives, then we go to the game over state. Otherwise, we're going to reset the player ship and then go into this new state that we've got, which is this respawn state. So looking at our respawn state, so this is our do ship respawn. So again, we're doing exactly the same thing here by keeping anything going that needs to be kept going, which is basically asteroids, player bullets, and the game info screen. And that's just a direct copy of the code above. And then we come into doing our find a safe respawn position. So I'm using another while loop here. So again, we're doing the same idea. So we're going to use a while loop and we're going to go through every single asteroid. Now in this one, we do have to check every asteroid because if any of them are too close to our respawn position, then we need to stop the respawn happening. So I'm creating a local flag, which is going to say that my asteroids are too close. And that's going to start off being false. I'm using my index counter again to count up. And we're saying here, so while we are working our way through all of the asteroids, and we haven't yet found one that's too close, then we keep looping. The check we're doing then is using this check separation function. So remember we wrote that, which just simply takes in 2 positions. So our player ship position, and remember that's already been reset back to its starting position. And then the position of the current asteroid we're looking at. We then tell it what is the minimum separation distance that we need between these 2 points. And again, we set that as that constant variable. And then that will send us back an answer which says true if the 2 positions are too close together, or false if they're too far apart. So if the 2 positions, so this player ship and one of the asteroids, if they are too close together, then we set our flag saying that one of the asteroids is too close. So in our while loop then, so if we do find an asteroid that's too close, then the next time we go around the loop, we will fail on this test, which means that our loop will exit as soon as we find the first asteroid which has got too close to our spawn point. And again, there's no point checking anymore. It doesn't matter if 2 or 3 are too close. If even one's too close, then that's all we need to know. So by the time our loop ends and we get down to this statement, then either we will have not found any asteroids too close and our flag will be set to false, or we will have found the first one and our flag will be set to true. So if we do not have any asteroids that are too close, then it's going to be safe to respawn, and we simply change our game state then to the play state. Otherwise, we just do nothing, and our code will come back through here again and check after the next 60th of a second. So that's all of our code written then to do this checking. So let's go and see if that works. So starting our game off then, we come in and we can start to make some extra asteroids. So we've got something to sort of dodge. And now if we let that one hit us, oh, just miss us, that one hit us there, we should find that the game pauses until it's safe to generate our ship, and there we go. And that gives us time to move out of the way before we start going any more. And then it pauses again. And again now if we... that, and there we have our game over. So we've now got our main game working. So we can shoot asteroids, we can be hit by asteroids, and our system will then count down our lives, and once we need to respawn our ship, it will respawn us, but giving us a chance to dodge any asteroids that could be coming towards us. To finish this lesson off then, there's a couple of cleaning up things we need to do. So if we look at our do ship respawn, we've got this block of code here which we said keeps the game display going. And we said that was an exact copy of the bit in this function here. Now, that's one of the things you should always look out for when you're writing your code is duplicated areas. So instead of having this area and the area beneath it then as separate blocks of code, the problem will arise is we haven't yet finished all of the game yet. So there may well be bits that we need to add into this code. Now, if we have multiple versions of this code lying around, then we have to remember to update every single version of it. So what the best thing for us to do would be to cut this out and extract it into its own function. So if we come down here and the amount we need to get, if I can go up here, so we need to cut that bit out, so I'm cutting that out. And I'm going to then just simply in here, I'm going to call a function. So I'm going to call do no ship display. So I'm going to call that function. So do no ship display. And then after here, I'm going to create that function. So function do no ship display. And I'm simply going to paste back in that code. And this is the end of that function, do no ship display. And inside there then I can then take out some of these lines. Again, I left them in so we could see that that was actually just doing it the same as the other code. So we've got that. And then our draw screen, we just need to draw those. So that's our do no ship display. So if I copy that name there, so in our code here, so our function do ship respawn, it does the no display code and then does the waiting for the safe respawn position. And then up here then, of course, we can take out this block of code and replace it then with that do no ship display code. So that just means then that as we keep on developing our code then, if we want to in here, and as a hint, we're going to do some explosion effects in a while. And obviously while we are waiting for the explosion effects to finish, we'll need to be drawing them. So we're going to be updating this code. And this means then that anywhere where we are doing this, keeping the display going without the player ship on screen, then that will be updated as well. We don't have to go and modify multiple versions of the code. But this also makes it very easy for us now to, in our start screen, so if we run the code, our start screen here doesn't really do very much. It'd be quite nice to have some asteroids flying around on that as well. So we now have an easy way of doing that. So if we come up to our do game start screen, we can see here that we have our printing up that message. But we could come in here and we could say, at this point here, we can say do no ship display. And at that point then it will start to display things. Now we do have to be careful here, because at this point in our game we haven't yet initialized the game, which takes place here. So really what we want to do is we want to initialize our game before we get to the do start screen function. So let's see if we can work out how we're going to do that. If we have a look at what our init game function actually does then. So if we go down to init game, it's designed to set the game up at the moment for the very first running of the game. So at this point, as soon as we init the game, it goes into our play state, resets the scores and lives, and then resets our player ship and generates our asteroids. Now we're going to use this init game to be able to reset our game at certain points in the system. So I'm going to take out this automatic game going into the play state for now, because again, if we're going to initialize at the very beginning and we want it to go into the start screen, we can't have it jumping past that straight into the playing state. So we're going to take that bit out, and whatever code uses init game, it will have to work out what state it needs to drop into. Now we're also going to have a look at our generate asteroids function. So let's come down to generate asteroids. And what that does at the moment, this is assuming that our asteroid array is empty. Now at the very beginning of the game, that's actually true. But once we are restarting our game, we're actually going to have asteroids left over from the old game. So our init game function, if we're using that as almost like a resetting, it's going to have to clear out the asteroids first. And the easiest way to do that is to take our asteroids array and set it equal to an empty table. So that will mean that any time we call generate asteroids, which of course is called from our init game function, we will automatically clear out any asteroids that are left over from any other game. And this will also then work when if we're using our start screen to have some asteroids flying around, and we then restart, and we then actually go and start the game, we want to clear out any of the asteroids which may have been in the middle of the screen and just restart with a fresh set of asteroids. So that will be a good thing for us to do anyway. So our init game function is now setting everything up. Our generate asteroids is making sure that we don't have any old asteroids lying around. So let's try and work out how we're going to get that then to work within our do start screen. So come back up here to our do start screen. Okay. So before we get into do start screen, we will want to have called init game. And that will then set up a number of asteroids, and then our do no ship display will display those asteroids and not be monitoring for any collisions with the player ship. So once we are in that area, if we press the fire button, then we want to init the game, but we also at this point then want to make sure that we set our game state to gameplay. So again, it's that line of code there that we want to copy and put in after that. Because remember, we had taken that line of code out of our init game function. So we now have to explicitly do it here in our start screen. But our init game then, we need to then call that at the very start of the whole code running. So if we copy that, we could try and put it here in our main block of code at the start and put it in here. But Tick80 and Lua, they don't allow you to do that. You can't call a function until you have defined it. So our function definition is somewhere down later in the code. So if we try and run that, we'll actually find that it tells us that we're trying to call a function which does not exist yet. That's what this error message means. This init game function doesn't exist. So if we go back into our code, what we need to do instead is basically build on our game state function. So we're going to have a game state which happens before the start state, and that will be the initialization state. So coming up here then, looking at our states. So let's put in a state init, and we'll make that equal to, let's make that equal to 5, and we'll change that one there to 8. So they're all sort of make sense now. So, and again, by changing it here, it makes it then that we anywhere in the code where we're using those numbers, they're automatically changed anyway. So we can do whatever we want here, really. So I'm going to say now my init state is simply going to initialize my game and get things on the screen. So down here then in our tick function, so again we're going to do a similar idea here. So we're going to copy that. I'm going to paste it in there. This now becomes an else if. So if game state is state init, then we don't have to have a special function here, because all we're going to do is two things. We're going to initialize our game, and then we're going to do our game state. We're going to do our game state equal to state start. So when our game first starts off then, so we don't need to do this anymore, we're coming up here, and our game state is going to be state init. So our game will start off, the very first tick, we will be in state init. So we will initialize the game, which sets up our player ship and our asteroids. And then we will jump into the state start. So the next time round, we will then hit this bit of code and do the start screen, which will be displaying things on screen and then going off and waiting for us to press the start button. So hopefully that should now work. And there we have a much more interesting start screen where we've now got our asteroids flying around. When we press our Z key then, that should then reset our asteroids, so the ones that are in the middle of the screen should disappear and we should be into our game. And there we go. But now, if we just kill ourselves here. Okay, so in our end screen, so with this screen here, what we really like to do is to have the asteroids that were left over from our game just flying around until again we press the Z key. So let's come back in here and go to our end screen. So at the moment we're just clearing the screen. So again, we can copy some of the stuff out of here. So instead of just clearing the screen, we want to come in here and we want to do our no ship display. We also want to then set it doing our game over message. And then if we press the fire button to restart the game, at that point we want to reinitialize it so that we get our empty asteroids, our asteroids respawning and our player ship respawning. So that should now give us a nice end screen. So let's run that and see what happens. So we have a nice start screen. We start the game. We die. We die. And when we get a respawn at some point soon, we die. And now our game over screen then, of course, is left with the same asteroids that were at the end of our game. And if we press Z to restart the game, we should now be back to the game starting from scratch again. Right, so that really gives us almost a full game now. So we've got everything working, we've got all of our shooting working, and our lives working, and our restarting and our start screen working. But what we need to do next is our explosions are a bit boring at the moment. So let's try and pep those up a bit in the very next lesson when we'll have a look at something called particle effects. So make sure you save what you're doing. Make sure you visit the course page. I'll put a link in the description down below because again you can download all the code for this. You don't have to retype it from looking at the screen. You can download the code and just paste it into your TIC80 code. And I look forward to seeing you then in the very next lesson. So have fun coding. See you soon. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.